friends, I am Ayushi Agarwal and I am working here as a verified educator on Unacademy. I have already added courses on control system and digital electronics, and in this lesson I am going to continue with the construction of root locus, the rules for the construction. You can also follow me on Unacademy's learning app and you can subscribe our YouTube channel. Control system. So before starting my lesson, I would like to give a brief introduction about myself. I am a BTech graduate from Hindustan College of Science and Technology in Electronics and Communication Engineering with First Division Honours. You can rate, review and recommend my videos among your friends, and you can also follow me on this given link below. The target audience. So this course is basically targeted for all those who are aspiring for GATE and all those who are pursuing their engineering, as control system is engineering subject, third year ECE subject. So for those who are pursuing, they can go through this courses, as these courses are very beneficial and there are many questions asked in your university examination based on these topics. And for those who are aspiring for GATE, they can also go through my courses, as I've been adding few of the previous year GATE questions in every course, in every topic. The quotation for the day is, "Aim for the moon. If you miss, you may hit a star," by W. Clement Stone. Weightage analysis of control system. So if you'll go through the 12 years, last 12 years weightage analysis, you will come to know that around 9 to 10 marks every year control system carries. And so these marks are totally in your hand. You can score well, you can do very well. If you will go through the topics and if you will understand this topic, you can easily score them. Construction of root locus. In the previous lesson, I have already discussed the 4 rules for the construction of root locus, and in those rules I told you about what is P, that means the number of poles, the number of zeros, how to calculate the value of n, the root locus branches, and how we can calculate the centroid, and how we can calculate the angle of asymptote. So we have already discussed those steps in the previous lesson. Now in this lesson, I am going to tell you about the further rules for the construction of the root locus. So there are 3 more rules left for the construction of root locus. The first rule says, find the intersection point of root locus branches with an imaginary axis. So what we have to do is, we have to find the intersection point of the root locus branch with the imaginary axis, that means JW axis. We can calculate the point at which the root locus branch intersects the imaginary axis and the value of k at that point by using the Routh array method. So basically, we can calculate the point at which the root locus is intersecting the imaginary axis and the value of k itself just by using the Routh array method, and that too in that case too. And I have already explained Routh array method, that is RH criteria, Routh-Hurwitz criteria, in my previous course very deeply, and I have also discussed many questions on that topic. So if you find any problem, then you can go through my previous course about RH criteria. So if all the elements of any row of the RH array are 0, then the root locus branch intersects the imaginary axis and the vice versa. That means if all the elements of any row are 0, then the root locus branch intersects the imaginary axis. So these are the conditions by which we can determine the intersection of root locus branch with the imaginary axis. We have to identify the row in such a way that we make the first element as 0, then the elements of the entire row are 0. Find the value of k for this combination. That means we have to make the adjustment in such a way that the first we keep the first element equal to 0 and the other elements of the entire row are already 0. And then we'll take out the value of k from that condition. Now what we'll do is, we'll substitute this k value in auxiliary equation. You will get the intersection point of the root locus branch with an imaginary axis. As I've already told you that we'll make an auxiliary equation. In making an auxiliary equation, first we have to make the root array method. Suppose 1 plus GSHS is equals to 0. This is the characteristic equation. We know the value of GSHS. We can find the characteristic equation are directly written in this question. S cube plus 7s square plus 10 plus ks plus 6k is the characteristic equation. Now we'll keep the coefficient of this equation in the root array table. 1 over here, 7 over here, 10 plus k over here, 6 over here, 6k over here. Now we know that we'll multiply this by this minus 6k into 1 divided by 7. So the final is 70 plus k upon 7. For this term will be 0 as 7 into 0. So this term will be 0. Now for this row we can see that if we keep this first element of this row as 0, as the other element of this row are already 0. But if we keep this term as 0, and then with the help of this equation we can find out the value of k. So what we'll do is 70 plus k upon 7 is equals to 0, from which k is equals to minus 70. So this is the answer for k is equals to minus 70. Now the third step says, substitute this k value in auxiliary equation and you will get the intersection point of the root locus. So we have to substitute this value in the auxiliary equation. The auxiliary equation is made by the equation just opposite to this row. So 7s square plus 6k, and we'll replace this k from here. So 7s square plus 6 into minus 70, we'll get the value s square is equals to 60. So s is equals to plus minus under root 60. So this is the value obtained for s. When the value of k is positive, then it does not take auxiliary equation method and it does not show the interaction with the x's. So this you have to keep in your mind. So by this we can find out the interaction with the imaginary axis by using the root array methods, by using the case 2, and by following these steps, these 3 steps. Now the next rule is find breakaway and break-in points. The breakaway point is the point on root locus where 2 poles meet. Once the 2 poles meet, they break away from real axis. So the steps to find the breakaway and the break-in points are, the first step is write k in terms of x from characteristic equation. What we have to do is, like we have characteristic equation which is in the terms of s and k. So we'll make k as a subject and we'll write the equation. Now the next step is we'll differentiate this k with respect to s and make it equal to 0. So we'll differentiate this k, that means dk upon ds, and we'll differentiate the all other elements and then we'll keep it as 0. Now find the value of s for which k value is positive are the breakpoints. Now we have to solve this equation, and in this equation we have to find the value of s. So this is how we can obtain the breakaway points, and like when we'll discuss the example or when we'll discuss the question on root locus, then you will come to understand how to calculate. The 7th rule is find the angle of departure and the angle of arrival. So one of the most important point is we have to find angle of departure and angle of arrival only when they are imaginary roots. If the roots are real, then we do not find the angle of arrival and angle of departure. So angle of departure and angle of arrival can be calculated at complex conjugate open loop poles and complex conjugate open loop zeros respectively. The formula to calculate the angle of departure is phi d is equals to 180 minus phi. So for departure we use 180 degrees minus phi. For angle of arrival we use phi a is equals to 180 degree plus phi. Now how to calculate the value of phi? Phi is equals to sigma phi p minus sigma phi z, where phi p is the sum of all the angles suspended by poles and phi z is the sum of all the angles suspended by zeros. So this is how we can calculate the angle of departure and angle of arrival. So these were all the rules which are to be followed for the construction of root locus, and in the next lesson I will be discussing with one of the example. Like after going through that example, you will come to know how step by step we have to proceed further, how we can calculate the breakaway point, how we can calculate the intersection point, how we can calculate the centroid and the asymptote angle. So thank you guys for watching my video and keep learning.